Okay, let's skip number 12 for now because I'm going to do that on a separate slide. But let's scroll on down to matching graphs with their equations. So we have the following graphs, and we want to match them with the 8 equations below. So if we look at the first one, number 37, r equals 2. That is a circle with a radius of 2, centered at the origin. So it looks like that one would have to be choice E. 38, we have r equals 2 cosine theta. And if you refer to your sheet, that would be a circle, and it would have symmetry around the x-axis. So that would have to be choice F. 39 is r equals 2 sine theta, and that is also a circle, but it has symmetry around the y-axis. So that would have to be choice G. For 40, we have r sine theta equals 2, and if you remember your polar equations, r sine theta is the same as y. So we have the equation really y equals 2. And if you look up at your graphs, that looks like it matches up with graph C. For 41, we have r cosine theta equals 2, and r cosine theta is x. So x equals 2 definitely matches up with graph B. And then for 42, we have 2 plus 2 cosine theta. And if we look at our sheet, that's definitely one of the limesons. 2 over 2 equals 1, and it's a cardioid. So that would match up with graph H. And then finally, we have theta equals 3 pi over 4. And what that is it is the line that covers that angle. So that would match up with graph D. And then finally, 44, we have theta equals pi over 4, and that would be the line that matches up with that angle. So that would be graph A. Okay, let's begin filling in the table for problem 12. So we have the equation 4 sine 3 theta. And if we look at our graphing sheet, we know that this is going to be a rose curve with 3 petals. So the first angle that we're given in the table is 0. So let's do 4 sine of 3 times 0, which is just 0. And if we make our little unit circle over here, we know that the sine of 0 is 0, and that would just be 0. Then we want to plug in pi over 6, but multiply that by 3, so that would be 3 pi over 6, which is the same as pi over 2. So the sine of pi over 2 is 1, and 1 times 4 is 4. Then we're going to plug in pi over 2, but we need to multiply that by 3, so we get 3 pi over 2. And the sine of 3 pi over 2 is -1, so times 4 would be a -4. Then we're going to plug in 5 pi over 6, but we need to multiply that by 3, so that'll turn into 5 pi over 2. 5 pi over 2 is the same as 3 pi over 2, so the sine of that is 1. So we need another 4. And then lastly, we'll plug in pi, but we need to multiply by 3. So we're going to do the sine of 3 pi, which ends up being the same as the sine of pi. The sine of pi is 0, and so we get another 0. Because we got 0 for the angles 0 and pi, we know that those are the zeros, or kind of like the asymptotes of our graph. So at 0, I'm going to make a little asymptote, and at pi. All right. It looks like that the other 3 angles are the angles for our maxes and our mins. So I have a coordinate at 4 comma pi over 6. So I'm going to go along pi over 6, which looks like it's about right here. And I'm going to go up 4. So let's see, 1, 2, 3, 4, about right there. All right, and at pi over 2, I have a coordinate at negative 4. So instead of going up pi over 2, I need to go down pi over 2. So I have a point at about right there. Oops. There we go. Kind of erase that little work. Okay, and then finally, at 5 pi over 6, I have a point at 4. So 5 pi over 6, about right there. And I'm going to go up 4. So about right there. All right, and now I'm ready to draw my petals. So I have a petal right there, petal right there, and one more petal right there. And that is my rose curve. You do need to know how to find the zeros and the maxes and mins on your own. So we're going to go one more slide and review how to find zeros and maxes and mins for a problem like 4 sine 3 theta. Okay, to find the zeros for 4 sine 3 theta, we want to first set it equal to 0. So we just end up getting 0 equals sine 3 theta. So we want to figure out, where does sine equal 0? So we make our unit circle. We can see that sine equals 0 at 0 and pi. But we need to write that in general form. So we have 3 theta equals 0 and pi, which would be 0 plus pi n, or just pi n. So we have theta equals pi n over 3. So we need to list all of those zeros out. So our first one would be at 0, and then at pi over 3, 2 pi over 3, pi, (4 pi over 3), and at 5 pi over 3. Okay, the next thing that you would need to find, so these zeros would act as your asymptotes on the graph. And as you can see before, we definitely had asymptotes at 0 and pi, because when we plugged those in, we got 0 in our table, and that helped us graph our graph. If we fully graphed it, we would have all of these zeros graphed, and that would shape all of our petals. So now we're going to find the maxes and the mins. So to find the maxes and the mins, first we need to set sine 3 theta equal to 1 and equal to negative 1. And looking back at our unit circle, we see that sine equals 1 at pi over 2. And sine equals negative 1 at 3 pi over 2. So writing this in general form, we have 3 theta equals pi over 2 plus pi n. And when we divide by 3, or multiply by a third, we get theta equals pi over 6 plus pi n over 3. So we get maxes and mins at the angles pi over 6. Let's do some common denominators and convert that to 2 pi over 6. So the next one would be at 3 pi over 6, which would be pi over 2. And the next one would be at 5 pi over 6. And remember, these 3 values were the 3 values we had in our table that helped us form our 3 petals. But we do have more values that work. They just end up being points that repeat. So the next 3 angles that would give us maxes and mins would be 7 pi over 6, 3 pi over 2, and 11 pi over 6. When you are doing this on the test, if you know that there's only 3 petals and you find the 3 angles that can give you those 3 petals, you can plug those into the table. That's okay. All right, so then these would be the values that you would plug into the table, plug them back into the equation, and you would get the rose curve that we got on the last slide.